We can use the chain rule to differentiate an exponential function with any base where a is greater than 0. So recall that from section 1.6 that a is equal to e to the natural log of a. So we can say that a to the x is going to equal the value of a. So we're going to replace a to be e to the natural log of a, and that's raised to the power of x. Okay, which then equals the following. It would be e to the power of the natural log of a times x. Okay, now if we use the chain rule, then the chain rule is going to give us the following. So if we want to find the derivative with respect to x of a to the x, well, that's going to equal the derivative with respect to x of e to the natural log of a x. So what we're going to do now is we know that by using the chain rule that we have e to the natural log of a x, and we're going to multiply that by the derivative with respect to x of the exponent, which is the natural log of a of x. So what happens here? So we end up getting e to the power of the natural log of a to the x, and the derivative of the natural log of a to the x, since the natural log of a is a constant, that means we get the natural log of a. And so what do we know about e to the natural log of ax? Well, we know that that's a to the x power. So that means we can substitute now this to be a to the x times the natural log of a. So what does that give us? Well, that's going to give us our new definition. That means that when we have the derivative with respect to x of a to the x, it's going to equal a to the x times the natural log of a, where natural log of a is a constant. So let's just say that if we let a equal 2, we would get the derivative with respect to x of 2 to the x is going to equal 2 to the x times the natural log of 2. And then in section 3.1, we gave the estimate from our example that the natural log of 2 was around 0.69 times 2 to the x. So this is consistent with the exact formula 6 because the natural log of 2 is approximately 0.693147. Okay, now, the reason for the name chain rule becomes clear when we take a longer chain by adding another link. So suppose that we have the three functions. Y is equal to f of u is equal to g of x, and x is equal to h of t, where f, g, and h are, f, g, and h are differentiable functions. Then to compute the derivative of y with respect to t, then we're going to use the chain rule twice. So that means we would have dy over dt, which is going to equal dy with respect to x times dx with respect to t. And so therefore that's going to equal dy over du times du over dx times dx over dt.